Today's question is A equal to 3 by 3 matrix. The first row is 1 0 0. The second row is 0 4 minus 1. The third row is 0 12 minus 3. Then sum of the diagonal elements of the matrix A plus I whole raised to the power of 11. So we need to find out this matrix and do the sum of the all diagonal elements. That we need to do. Let's see how to solve this. So what they given A is a 3 by 3 matrix. First let's observe what is A power 2. That means we had to do A times A. So do you observe this 1 0 0 0 4 minus 1 0 12 minus 3, which is nothing but our given matrix A. That means if you do A power 2, we are getting A matrix only. That means if you do A power 2, we are getting A. That means if you do A power 3 also, similarly we are going to get A only. Up to so on, what we have whole raised to the power of 11. That means if you do up to A raised to the power of 11 also, we are getting A only. Now take this, the given A plus I whole raised to the power of 11. Let's use the binomial theorem here and write the terms. So what we are going to get, 11c naught A raised to the power of 11 I raised to the power of 0. I raised to the power of 0 is nothing but only 1. A raised to the power of 11 is nothing but only A. Isn't it? So instead of A raised to the power of 11, simply we can write this as A. Plus, what is the second term? 11c1 A raised to the power of 10 times I raised to the power of 1. So A raised to the power of 10 is nothing but A. So A times I is nothing but A. And like that up to so on. Just write last two terms, before two terms. That is 11c10 A raised to the power of 1 is A only, then I raised to the power of 10. So I raised to the power of 10 is nothing but I only. So A times I is nothing but A only. So just simply write this as A. Plus, now write the last term. 11c11 I raised to the power of 11. So I raised to the power of 11 is nothing but only I. And 11c11 is nothing but only 1. So here we can write this as only I. The first all the terms we have A except this, the last term. So the expression A plus I whole raised to the power of 11 after using the binomial theorem. So what we got? We got 11c naught A plus 11c1A up to so on 11c10A, and then the last term we are getting 11c11 I raised to the power of 11 is nothing but only I. So the last term only I. So from first all the terms we have A as common. So let's take it A as common. So then what we left? We left 11c naught plus 11c1 and so on 11c10. So if we have a summation k equal to 0 to n, nck, the formula is 2 raised to the power of n. So here n, you can take this as 11. So then here also we just take it as 11ck. So here also we can write this as a 2 raised to the power of 11. So this summation formula is for 0 to 11. But in our expression, we are taking only up to 0 to 10. 11th term, we got this as a only identity matrix I. That's why we have to subtract the 11th term here. So that means 2 raised to the power of 11 minus 11c11. So finally, instead of this 11c naught plus 11c1 plus 11c10 up to so on 11c10, we can simply write this as 2 raised to the power of 11 minus 11c11 plus I. 11c11 is nothing but 1. Now we need to simplify this. Then we will get the expression A plus I whole raised to the power of 11. So this is A. 2 raised to the power of 11. What is the value of 2 raised to the power of 11? Which is 2048 minus 1, which is 2047 times A plus I. So what is our given question? We need to find sum of the all diagonal elements of the A plus I whole raised to the power of 11. So after simplifying, we got this expression, which is 2047 times A. So now you have to take the diagonal elements of this given matrix A and the identity matrix I. So what is the diagonal sum of the diagonal elements of A? 1 plus 4 minus 3, which is 5 minus 3, which is 2. The sum of the diagonal elements of A is 2. So instead of A, we can write this as a 2. Then what is the identity matrix sum of the diagonal elements? Which is 3. Sum of the diagonal matrix of the identity matrix is 3. So after multiplying, then we are going to get 4094 plus 3, which gives 4097. These are the sum of the diagonal elements of the given matrix A plus I whole raised to the power of 11. So 4097. So like that we need to find out. That's it. If you like this content, please like, share and subscribe to my channel. Thank you for watching.